myself. Okay. 2.4, library parent functions. My microphone's on somewhere. I heard myself. Got it. Thank you. Appreciate that. We're going to talk about linear functions. We're going to talk about the squaring function, which is also known as the quadratic function. We're going to talk about cubics. We're going to talk about square roots, the reciprocal function. Randomly, it throws in an absolute value function, and we never talk about it, but it just all of a sudden, there it is. I don't know why. The deal is on parent functions is you should be able to look at a graph and know what the parent is. Where did it come from? Okay, that's the whole concept of parent functions. Oh yeah, and then your favorite piecewise functions. And that's number 10 on the homework that I can't figure out how to do. I can't figure out how to enter in the computer. I know how to do the problem. So I didn't. But the watch it and read it don't ever talk about how to actually enter an answer on the homework, does it? They just show you how to do the problem itself, right? I understand that. Yeah. No, BioSig wouldn't have that. Okay, so characteristics of the parent of the linear function. Domain is all real, right? If I'm drawing a line, x can be anything. If it's a function. Slope can't be 0. Why not? Well, it's still a straight line with. Okay, so if I'm talking about this function, I mean, someone could argue and say that a horizontal line is, and it really is with a slope of 0. But if the slope is 0, this next line doesn't hold true. If the slope is anything but 0, what's the range going to be? All real numbers. What happens when the slope is 0? The range is whatever this number is, right? Okay, so that's why this m is not equal to 0 there. The graph of the intercept, to find the x-intercept, you plug in negative b over m, and that'll get you the x-intercept. To find the y-intercept, well, it's b. If the line's going up, it's increasing. Slope is positive. If the slope is negative, the line's going down, it's decreasing. Okay, so I want to write the linear function f for which f of 1 equals 3 and f of 4 equals 0. What would y'all do? How would you start this problem? Do you see any coordinates up there? 1, 3 is one of the coordinates. Okay. Writing in purple or magenta or whatever color that is. Okay. Yeah, so they didn't give us points like we're used to seeing, and that's okay, right? As long as we know that this is x, plug in a 1, you get a 3, that's the output. Okay, great. I know 2 points. Now what? I want the equation of this line. Okay, so you want to be able to write that, and now from there, you're just going to write down the answer, right? Really? Okay, great. What's B? What's M?
I'm trying to remember what the name of that formula is.
What's that? No. Slope. Yeah, we need to find the slope, which is y2, y1. Okay. Now what? Okay. So which one do you want to plug where? Does it matter which one's 0.1 and which one's 0.2? No. Okay. As long as you're consistent, right? I've actually seen some people, they write the formula for slope as y1 minus y2 over x1 minus x2. Is that okay? Is it the same? As long as your 0.1 and 0.2 are together, right? All right. So it doesn't matter however you want it. You know, a lot of times when I write it down this way, since the x2 and y2 are on the left, a lot of times I'll go, well, I'll just make this 0.2 then, right? So it doesn't matter. You don't have to label them like I am. The only reason I do this is so that I don't, you know, all of a sudden switch my X's and Y's, okay? Okay, so based on the way I have labeled these points, my slope would be 3 minus 0 over 1 minus 4, which gives me, which is okay, so it's -1. Now what? You want to use a point slope formula? Okay, what I'm going to do here, folks, is I'm going to do it 2 different ways. I'll start off with point slope formula. Let me take, hello, put that back. No, you can't see under there. No, I guess you can. All right, let's put that there. What's point slope look like? Okay, and I want to point something out. If you look very, very closely, these 2 equations right here are exactly the same. Can you see it? If I took this equation and multiplied both sides by x2 minus x1, wouldn't I basically have this? Okay, so this formula comes from the slope formula. Okay, do I have to use this x1 and y1? Because that's what my formula says. Okay, it doesn't matter, right? Do I have to use the -1? Okay, so I know m, and then I can use either point. Now, for the purposes of this problem, I don't care if I labeled this P1 and P2 to begin with. For this equation, I would have used this guy. I like plugging in zeros. I don't have to do math that way, right? So if I use that, so I'm gonna plug thing in. I have y minus y1, which is 0. Okay, I'm gonna be lazy. I'm not writing that down. Equals m -1 times x minus 4. Is that slope intercept form? Okay, distribute to -1. Y equals. Okay. And this would be the linear function f. And I guess to make it happy, we probably should write it as f of x equals, right? Okay. I don't know. Mhm. Let me ask you this. So let's ignore this part down here. We haven't done this yet, okay? So I'm at this point right here. From this spot, can I use that equation? Have you ever tried this before? Do I have some x's and y's? Do I know what m is? What do I not know? So why don't I just say, well, let's choose this point because it looks easy. If y was 0, so I'm gonna take this guy, plug it in here, this guy over here, and this guy right here, right there, right? So I got 0 equals -4 plus b. Get b by itself. B equals 4. No, this is totally legal. 100% legal. Legal. Is this m? Is this b? Can I write the equation y equals mx plus b? Y equals m x plus b. Oops. Which is 4. Okay. Why? Has anybody ever actually done it that way? That's how you do them? Okay. A couple of people from second period said they've done this before, this way. Okay. That's okay. And the best way to do it, whatever works best for you and you understand this. I'm going to go through a couple slides real quick. They're just kind of working it out. That's exactly what we got. And they graphed it. That's what it looks like. Two special types of linear functions, the constant function. The constant function is just a horizontal line because it's a constant, right? Domain. What's the domain of this line? All real numbers. What is the range of this function? What is the range of this function? C, right? Whatever that number happens to be. Yeah. Okay. The identity function is just y equals x. Identity function. You are your own identity, right? The way the identity function works is, okay, give me an x value. You give me an x value. 4, y is 4. Give me an x value. Y is 5. See what's happening there? So the identity is whatever you put in is what you get out. That's the identity function. Okay. The domain and the range instead of all real numbers, the identity function has a slope of 1 and y-intercept of 0. So the graph of the identity function, folks, that is the parent function. Okay. Moving right along. Not going too fast, too slow, just right. How we doing? No arguments? Okay. The squaring function we call a quadratic. It looks like a U. Domain is all real numbers. The range is 0 and up, right? Okay. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. Do negatives, same thing, right? So the range is all non-negative real numbers. The function's even. What's that mean? Equal on both sides. Symmetric. Okay, an even function is symmetric about? An even function is symmetric about the? It's a specific axis of symmetry. What makes an even function even? Huh? X-axis, it's symmetric this way? Y-axis, okay? An even function is symmetric about the y-axis. The graph has an intercept at 0, 0. It has one intercept, which is both the x-intercept and the y-intercept. More stuff about the squaring function. It's decreasing from negative infinity to 0. It's increasing from 0 to infinity. Symmetric with respect to the y-axis. So it's kind of repeating itself here. If a function is even, then by definition of an even function, it is symmetric about the y-axis. Saying this twice is actually repetitive and redundant. Just like saying repetitive and redundant. Okay. The graph is relative minimum at 0, 0. And y'all okay with what a relative minimum is? Relative minimum means in relation to the points around it, it's going to be the lowest, right? And there's a graph of it. Moving right along. The cubic function. What's it look like? Don't look at your calculator. Don't graph it. We've talked about it before. I'm testing your memories. What does the cubic function look like? Without trying to get ahead, I'm looking at notes. What's it look like? Anyone? Anyone? Bueller? Anyone? Like that? The cubic function. Okay. Domain. What numbers can you cube? What's the domain? You can cube any number you want, right? I can plug any number for x and plug it in. It's going to give me a y that goes with it. Range, look at the graph I drew. It goes down forever, it goes up forever, doesn't it? Range, all real numbers. It's odd. What's that mean? It is symmetrical. Odd is symmetrical. What is symmetrical? Okay. Now, it is not symmetric about a line. You can't fold it in half. It's symmetric about a point. It's symmetric about the origin. Meaning, you take any point on that graph, draw a line from that point directly through the origin until you hit the graphic. Now, this is a freehand graph. It might not be exactly right, okay? But if I was to choose, say, this point right here, and it's going to be hard to see, if I drew a line straight through, it's going to land exactly on it as well, okay? So it's symmetric about a point, symmetric about the origin. So that's what odd means. It has one intercept. It has both an x and a y intercept at the point 0, 0. The graph is increasing always from negative infinity to infinity. And I'm going to say this again. When you're talking about graphs being increasing, decreasing, and constant, we read from left to right, okay? And then it says right here, the graph is symmetric with respect to the origin. Again, another redundant statement. And that's what the cubic function looks like. The square root function. Read some characteristics here. It says domain is all non-negative real numbers. The range is all non-negative real numbers. Do you see anything about being even or odd? It's not. There's no symmetry whatsoever in the square root function, okay? It has an intercept at 0, 0, and it's always increasing from where it started. It starts at 0 and goes to infinity. What's it look like? What's the square root function look like? I'm testing memories, and our memories are failing us. No. Then it wouldn't be called a square root, would it? Yeah. Yeah, it's basically half a parabola. So the square root function looks like this. It's kind of half of a parabola, sideways. What would it look like if I was to graph plus or minus the square root of x? This would be, that right there would be negative square root of x. Now the blue graph by itself is a function, right? Is the red graph a function? The red graph by itself. Red graph by itself is a function. Put them together, not a function, right? Okay. That's gone. Okay. Moving right along. There it is. Reciprocal function, what's it look like? If the reciprocal function is 1 over x, what's that look like? We've done all these before, right? After I've drawn them, do they kind of ring a bell? Oh yeah, we've done that before. Okay. Reciprocal function, what's it look like? Reciprocal function. Reciprocal of x would be 1 over x. The reciprocal function is f of x equals 1 over x. What can you not divide by? Can't divide by 0. Therefore, can x be 0? No. So the domain is negative infinity to 0, not including, 0, not including, to infinity, right? That's the domain. Look at the range. How does the range compare to the domain? The same. What this means is, theoretically, I can take one candy bar and divide it by however many people are in the world, and I could give everybody a piece of candy bar. Okay? Because 1 divided by a trillion, is it 0? No. Is it small? And it gets smaller and smaller and smaller. Can it ever be 0? Okay? That's why the range is everything but 0. You cannot divide 1 by what, I don't care what number it is, you cannot get 0 out of that. Okay? That's why you have a horizontal asymptote on the x-axis. You have a vertical asymptote at the y-axis. Okay? It's odd. It's odd because it's reflected across the origin. Okay? Where are the x and the y-intercepts? Doesn't have any. Those are asymptotes. It can't equal if it's an asymptote. Partial lie for future problems. Okay, we'll fix that later. Because the graph can touch an asymptote. It's kind of weird. It's always decreasing except at 0. How come it's not decreasing at 0? Because it doesn't exist there. Isn't this weird? From negative infinity to 0, it's decreasing. And from 0 to infinity, it's decreasing. So magically, from negative 0.00000001, it gets from a very, very small number back up to infinity. And again, these two statements right here mean the same thing. But this time it's on the same slide. So I'll actually write something about it. Okay. Here's a picture of it. Okay. Know that on your homework and anything you see like this, if there is not a closed dot or an open dot, it's implied to be an arrow. Does that make sense? Okay, I don't like it. I think there should be arrows on here. But when you see something like this on your homework, it's assumed that it goes up forever and it goes this way forever, okay? Unless there's a dot that shows termination, okay? And a quick review of parent functions. We have the constant function. We have the linear function. Let's just, for the heck of it, throw something in we haven't talked about, the absolute value function. Not today. Not today. I will tell you, though, that the properties for the absolute value function and the properties for the squaring function are basically the same. Same domain, same range, same minimum, a lot of the same thing. There's your quadratic, your cubic, and your reciprocal function. You got all 7 of these together. And the concept is, folks, you should be able to recognize this shape, okay? If you see a shape that looks like one of these 7, you should be able to say, oh, that's the reciprocal function, but it's been transformed. Maybe it's reflected across the x-axis. Maybe it's been moved to the left or to the right or up or down. Last piece, piecewise function. A piecewise function is made up of pieces. In looking at the definition of a piecewise function, it will tell you explicitly what the domain is. Okay? For example, and this looks an awful lot like number 10 on your homework. I'm going to change this problem because I truly believe there's a typo here. This is a piecewise function and it's totally fine. There's nothing wrong with this piecewise function. The domain, can you tell me what the domain of this is? Domain as written. What is the domain? What can X be? Negative infinity to -6 bracket union. Okay, so as written, that is a domain. So is X all real? No, because X can't exist between -6 and 6. Can you plug 0 into this function? Because 0 is not defined as a part of the domain for this function. Okay, so I'm going to go ahead and erase that. I really don't think that this was the intent of the question. Let me make it look more like your homework. Now what's the domain? Okay, that's very redundant. Someone say it shorter. All real numbers. Negative infinity to infinity. Right? -6 plugs into what? If I was to give you an X value -6, which piece would you plug -6 into? The top one. Okay, -5. The bottom one, because -5 is greater than -6, right? -7. Top one. Okay. I'm going to draw a very, very rough sketch of this. Okay. If you remember when we were graphing these, I would tell you, I'd say, well, let's graph the line, right? Then I would put an open or a closed circle at one part of it, and we would erase. Okay. So let's look at the first one. What does the graph of X plus 2 look like? Like that. So it's going through 2 with a slope of 1. So going through 2. So let's plug in -6. If I plug -6 into that, which because -6 is reading backwards, -6 is my starting point for this, right? Does that make sense? Graphing backwards. Okay, if you plugged in -6, what do you get? -6, -4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. About here, open or closed circle? Closed circle with a slope of 1, right? But I'm going this way. Shall follow that? Okay, because my X values are decreasing. If I was to plug -6 into this equation, what would I get? I can't plug a -6 into it, right? But if I could, it's going to be an open circle, right? It's going to be an open circle. Okay, so plug a -6 into this, we get 1/2 of -6. -3 minus 4. -7. So -6, -7. 1, 2, 3, 4, 5, 6, 7. Open circle about here with the slope of up 1 over 2. So it's going to be not as steep as this one, right? Like I said, folks, this is a very, very rough sketch. Does that make sense? And see, once you find this point, if you go up 1 over 2, then you can draw your line on your homework. The question is, I don't know how to do that. Did you figure it out? Okay. What do you do? Well, let me pull it. Let me finish this real quick, and then I'll pull it up here and we'll show everybody. Okay. Questions on this? Okay. If I'm not mistaken, that's it, folks.